guys, so now that we've gone over a bit of how to just, make some stuff in Inventor, general like layout of what's happening here, right? We'll start making actual, design parts. So I'm just gonna, close out of these real quick. I don't need to save this. This is just a little test thing. So the first part that we're gonna start with is the chassis. So the chassis of the robot, as I mentioned in our mech workshop, is the base of our robot. That's where our wheels go. That's where, everything goes really in terms of the structure. Everything is mounted off of our chassis, and all of our electronics are housed in our chassis. So this is usually a good place to start when designing a robot, right? So we're just gonna make a new file right here, standard part. Right, so the way we're gonna design our chassis is we're gonna have it be 3D printed, right? And essentially, I'll just kind of make a vague drawing to sort of give you the idea of how it kind of would look. So essentially, we're gonna have like a rectangle, right? And then we're gonna have this, right? So it'll kind of be something like this, right? I'm putting in random dimensions just to give you a visual. So it'll be sort of like a box, and then our wheels will kind of go on the sides, and then we'll put like a little floor in there with holes cutouts for the wheels. I don't know. I'll just quickly give, something here. Right, just so there'll be like a little bit of a floor. Right, put 4 squares for our cutouts, for where the wheels will go. Right, again, this is very rudimentary modeling just to give you guys visuals, So yeah, that is really thick. What did I mess up? I don't know. Anyways, yeah. So yeah, the wheels will kind of go through there. Your motors will be over here, right, on the sides, and that'll sort of be a decent frame for your robot to start off with. Is this the optimal frame for your robot to start off with? Not necessarily, but I'm just sort of here to give you a general idea of how you can go about designing your robot. And this is just a demonstration of a medium level robot that can do okay at the competition. And after this, it's sort of up to you to make the optimal design. So yeah, anyways, let's just kind of start from fresh. This is just sort of a quick walk through of like what we're trying to do. Let's just delete all that. And I actually would like to start on, let's start on we can start on the base. So first thing we're gonna do, right, we want to start on the bottom, and that'll be down here. So we can just make a rectangle. And so note for something when you're CADing is you want to do a lot of your modeling about the center point, because that just sort of makes your life a lot easier, right, in terms of, how your planes line up, right? Then everything's aligned to these, coordinate axes, and constraining stuff in your assemblies become a little bit easier, and your parts just a little bit cleaner, right? And it's easier to put together. So that's why I recommend, so usually when you, open a part, make a new part, right, it'll give you this 2-corner rectangle. I suggest always switching to this 2-point center rectangle, because this rectangle, you define it by point to point and you do whatever. And that's okay, but it's a lot more convenient to usually define your rectangles from the center, right, like this. And then after this, we'll put in some dimensions. So our robot has a, first of all, 10-inch by 10-inch size restriction. That's just a rule for internal comp, right? It has to fit in a 10-inch cube, and we'll like put your robot in a literal cube to test that out at the inspection table, right? So now, of course, we don't want it to be this big. We're actually gonna change these dimensions up and make them a lot smaller so that you fit comfortably in there. Let's just make, like 7 inch. Yeah, 7 inches seems, fine. 7 inches by 7 inches, maybe 7.5 might give us a bit of extra, playing room. No, that's in millimeters. That's the default units. And then I'll pick like a round number in millimeters to kind of go off of. I just wrote it out in inches because it's just being American, my brain auto thinks in millimeters. But I intuitively know what 7.5 inches looks like over 192 millimeters, which is why I wrote that in first. And if you can define the units in here, and it'll, know what you're talking about, which is nice when you're making a dimension. And then something else nice is, so I know that we want our robot to be a square. At least I want this demonstration robot to be a square. You have free will, do what you want. If you go in here and you click on a different dimension, you can set this dimension to always equal that dimension. So it's sort of like an equation-based, dimension that's based on this one. This is like a variable. So if I change this, if I make this 200, this will also expand. So it's just a convenience thing. Let's bring this back to like 192 or whatever I put it. And this dimension isn't too specific right now. And we'll maybe change it as time goes on. And then we'll create that box structure we did earlier, right? And so we could make another rectangle, or we could just offset this rectangle here, this square here, and define the wall thickness, which is it just kind of goes in line with what we were talking about yesterday on the other video, right? Which was, does having your CAD software know what your design intent is? So there's this tool here, offset tool, keyboard shortcuts O. You can click on here and it is sort of like offsets this part. And so think about how we're making this, right? It's like we want walls, right? This is what we want it to be. And we want a wall of thickness 10 millimeters, which I'll kind of explain why in a bit. But essentially, for using the heat set inserts, it's just that we want the walls, thick enough so that, it sort of holds it in properly and doesn't make a mess, which is why I make them, 10 millimeters thick. And I'll show you that as when we design that section. So yeah, I want 10 millimeter thick walls. And so that's why I designed it using that offset tool. Now, something you might notice is that this is also 172 millimeters. If you hit M, that pulls up the measurement tool, and you can click on lines and see, how big it is. So another way you could make this is, using your rectangle tool, 172 by 172. But note that if I change this to like 300, this won't follow with. And knowing how we want to design a robot, we always want the wall to be, we're defining the wall thickness more so than the actual inside space of our robot. So that's why we want to use the offset tool instead to, create this feature. So yeah, here's that. Do that, finish that sketch, and we're going to use that extrude tool, E is the keyboard shortcut, and we're just going to extrude this all the way up. We'll give a tentative number of like, I don't know, 24 for now. We'll see how that works later on. But anyways, so now we have that square shape. Now let's sort of move on and let's try putting in the motors. So how are we going to do that? We actually have a CAD model for the motors inside the folder that you guys, downloaded already and put into your Inventor, folder, right? If I go into my documents, Inventor, right? Comp Robot 2025, right? The kit, and it's all in here. Your motors are in electronics. Right over here, you got in a step file, which is a very generalized CAD format. I gave it as that because, and not an Inventor file, because in case anyone wants to use a different CAD software. So the way you do that is you go in File, Open, and we'll go into Kit, and Electronics, and open up Motor. All right, so we'll just kind of hit OK. Right, those are just some settings for imports. And I'm just gonna do my whole like changing the viewer settings. Right, so we get those like clean lines. And so now we see this is what our motor looks like. And what we're gonna wanna do is we're gonna want to mount this onto this face here. And from there, we're gonna put the wheels. So in order to do that, we have these two screw holes in here that, we put the screws through and we can screw it into this, wall here. So that means we need holes here for the screws to go into. And more specifically, we're going to use these things called heat set inserts, which are, brass inserts. I can look some up for you guys to, see. Heat set inserts. Right. They're essentially these things. They go into a part, and into a 3D printed part, you can sort of like melt them into there and you can screw into them. And that's how you can screw threads into, 3D printed parts, like metal threads, right? And it'll be more stable than, say, printing a 3D printed, thread for your screw to go into, right? So what we'll do is start a sketch here, right? And we'll first actually we'll measure, the distance between these two holes is 17.5 millimeters, right? So we'll, make a, I'll actually make a line here of 17.5, and I'll make it a construction line because I'm using this as sort of like a geometry reference, right? And then I'll put two circles here, right, of size 4.5. So the screws holes themselves are 3 millimeters. Yeah. But for the heat set inserts, the inserts are a bit larger than the screw, and the right diameter for those inserts, the 3 millimeter screw inserts, they're called M3 screws, are 4.5 millimeters. That's just something you just got to know or look up whenever you design these sorts of things. Yeah, so 4.5 millimeters, right? Something you know is I made this line. This line was more of just a convenience thing, but you could also define how these two are related to each other using these constraints. So the first thing, notice that these two holes are, literally aligned with each other. If this is, the orientation, they're vertically aligned. So what we can do is use the vertical constraint to make them vertically aligned to each other. And then we can use a dimension. So here, dimension, you can click on that, or know the keyboard shortcut, which is D, because you use that a lot, right? So just D, and it's what, 17.5 as you mentioned before, right? So now these will go wherever. That being said, I do like doing it by the line because it gives us one extra thing we can do, in that we can also, let me just quickly, 17.5 is we can define it. We can use the center point of this, right, to define where it's located, which is pretty convenient, right? If we want this, so we have like the center of this essentially as like a geometry point we can use to create sketches with, right? So let me just make this a construction line. I'm CADing on a trackpad. This is kind of awkward, but anyways, yeah. So like I mentioned, actually, we're gonna actually have this centered. So now this point here, I could project it, or we can project the center point of this line right here and center it with here, because I know this line is the whole length of this, and the center is of course at the center, right? So I can use the horizontal constraint to make so that these two are lined up, the center point of this line and the center point of this line, so that this whole setup is lined up completely, right? So I'm going to make this construction. Probably doesn't make a difference, but it's cleaner. Anyway, so now this is, kind of free spinning only this way, free moving. And we'll define that later. It's not an important feature right now. Now we'll go into here, and something to note is that we have this motor shaft, right, and it's on both sides, so we need to account for that and put a hole on this side here so that this can go through and not phase through our frame, right? Because do this right, this hole is where it'll screw into the motor, and then that shaft will probably be like over here. Well, no, let me just drag this over here, right? Motor's over here, shaft is going to be over here, kind of sticking out, right? So yeah, what we'll do is we'll measure out where that is. What I like to do is I just create a sketch, and I can project these lines, and I can project these geometries here, and I can sort of just straight up measure it by creating lines, because the measure tool is sometimes a little bit limited, and it's just easier to make a sketch and just measure everything out. Make sure that's vertical. Well, I'm rotated sideways. Note that Inventor has like the vertical and horizontal constraints are relative to the global orientation and not where you're looking. So I'm hitting the horizontal constraint, but it's actually vertical from how we're looking, because we're looking at it sideways. If you look at this view cube, that's the orientation you're at. Anyways, so now we can measure this. This is 20.6 millimeters to the left, and well, relative to the center, it's in the middle, right? And you could also just measure this also with the measure tool, M, right? Oh, for the record, the measure tool, the button is located in tools, but I ain't going to the tools menu just to hit one button. Just hit M, right, and you'll get your measure tool. Anyways, let's control Z our way out of here. Or wait, I forgot the number. I think it was 20.6. Yep. Anyways, so let's control Z our way out of here, right? And let's go back here. We're still in our sketch here. So let's just make a circle. Oh, by the way, the keyboard shortcut for a circle is Control-Shift-C, or you can just click the circle button. But as you get more fluid in CADing, you're going to probably gravitate to just using your keyboard shortcuts. This shaft is like somewhere between I think it's like 4.5 millimeters in diameter. We want it to just have complete clearance, so I don't know, we can make it like 10 millimeters. You can do anything as small as like 5 millimeters, technically speaking, but I don't care to take risks like that. It's no real point. So anyways, let's just horizontally align it to the center, right? And then 20.6 here to here, right? Now, as I keep CADing, I'm gonna give you guys less details of everything I'm doing, because I'm assuming you're picking up on how this is working now. So I'm just gonna kind of start doing stuff, right? So I'm just gonna make a reference line here to the center, and I'm gonna make this construction, all of these ones, because I just projected this line too to get the center point. So now something to note is for a four-wheel, chassis, I'm gonna have one wheel here, one wheel here, but I'm gonna want it, mirrored, right? I want it all symmetrical. So what we can do actually is select these three circles. You can shift select them to select multiple, and then I can mirror that about a mirror line, and it'll, if you hit apply, it'll create a mirrored section right there. That's just a convenient thing. And again, tells Inventor what you want. Essentially, you want it to be mirrored, right? And say if you ever change it, it'll know. Anyways, I'm gonna define how far out it is. I don't know exactly how far out it has to be. We'll see when we assemble it. And so I'll just kind of give it a random number for now. And we can, essentially what I mean by that is we can take a measurement in our assembly and see how much we need to adjust that. So for now, I'm just gonna be like, that's okay. Finish our sketch, and I'm gonna extrude that. So now what I'm gonna do is I'm going to extrude this. So now there's two ways about going about this. One thing we do is we can actually, there's different types of extrusion, right? So first, of course, I mentioned last time, right? There's the the distance extrusion, right? And then there's the two-face extrusion, right? And you can maybe even go to like you know this face specifically, so you can cut this out here, or you can go to a different face, right? And then there's also the through all, which means it just kind of rips through the entire part. Now in this instance, actually this is the most efficient way to design it, because as you can see, we want it mirrored on the other side, and this kind of automatically mirrors it for us, right? So I'm just gonna hit OK and have it just cut through all of it. Yup. Something to note is, again, I made this vertical height just kind of randomly. It's kind of getting close to the edge of this, so I'm going to make this actually a bit taller. Just go back into the sketch, right, hit the drop down, double click the sketch to edit it, and I realize that's not the feature. I don't need to affect the sketch, I just need to make this taller. So I'm going to go in here, make it like 36, now 376, 36, right, it gives it a bit of space. And that's actually important because when we use the heat set inserts, the way we place them in the hole is we use a soldering iron to heat it up, and it sort of like melts its way inside. And so if there's very little clearance to the edge, it'll sort of like melt out a little bit and be really messy, and it won't line up properly. So yeah, that's why. Yeah. Oh, by the way, you can, redo things you undo by Control Y. Also works in Google Docs. But yeah, anyways. So that's that. I'll actually save this quickly. Put this in our chassis folder. And we'll just call it the chassis base. It's sort of like the base of our chassis. Or you can call it a frame or whatever you feel like. It's not that deep. And we'll actually start an assembly file, because then you'll kind of get a sense of how this is supposed to look now. So new, assembly, and we're going to place in our chassis frame base right here. And we're going to do what I mentioned last time, which is right click, place grounded at origin. And so something you know is that in our assembly file, the center of our assembly file is also, it's not the center of our CAD file. Well, that's because I didn't center this. Something to note is that you can actually do that and it'll like center it. But again, this is more of a cleanliness detail than anything. The whole centering thing, you don't need to go insane over it, not gonna lie. Yeah. I'm not gonna save that just yet. Anyways, get our lines in. Yeah. So after that, let's just import some motors in, and let's see if those motors fit in here. So kit, right, electronics, and motors, right here, and then I'll save it. Yeah, I'll just call this a chassis assembly, right? These were assembling your chassis. Something to note is it'll actually create inventor files of this motor, right? Because what I gave you is a step file, and after you save it, it'll create an inventor file for all of that. So give it a second to save. Right, and now let us place this motor in. Now I'm gonna place this side and not this side, because there's this little nib on here and I don't feel like designing that. So I'm just gonna, use this flat side for our convenience. So I'm gonna mate this to this face, and then I'm gonna line up the holes right here, here to here, and then this hole to this hole, right, using those, axis mates, right, and I'll go right there. So something to note is that this is actually clipping out the end, so clearly this, these motor holes are too far outwards and I need to bring them in. But let's also add in a wheel so we can even see that. on here. So let's just import, go in here, wheels. So we're going to be using Mecanum wheels, and something about Mecanum wheels is that, let me just pull this in. They're omnidirectional and they have a specific slant. So this is a left slanting wheel, which means let me just actually constrain this on, because you have to look at it from a top-down orientation in order to see what I'm talking about exactly, right? So just constrain that there real quick. If I look at it like this, it the top is slanted, right? And the higher side's on the left side and goes down to the right side. So this is a left slanted Mecanum wheel, right? Because it goes left to right like that. And then if we import the other wheel, you can get a right slanted Mecanum wheel. And I'm just going to delete you, or yeah, and I'll show you this one. Right here, and look at it from a top-down view. Let me rotate this. Yeah, now it starts on the right side and goes down this way. So just a little note about designing with Mecanum wheels. So from the Mech Workshop, you might remember that these wheels let you go in all directions, and that's what these rollers are for. And in order to have that functionality, you need to have these rollers pointing a certain way, where essentially you have 4 wheels, and these rollers should point to the center from a top-down view. Note it will look different from the bottom. As you can see, this is pointing away from the center from the bottom and towards the center from the top. It's an X from the top and an O from the bottom, and you'll see that after we finish putting in all the wheels, right? But anyways, let me just, so what the first thing I did, I'll just restart constraining this so you can actually see what I'm doing, right? Paste that again, is I'm gonna, so how it's gonna work is this face over here, right? The end of this, so we're gonna put it on the shaft, right? And so this bit here will end up pushing against the far inside of this piece on here on the wheel, right? And so we'll constrain those two together to create this. And then I want this shaft to be concentric with this one. Really, I can pick any concentric feature there, like that. Any circle that's, at the center of the wheel, essentially. So now this wheel spins and stuff. We can see that the wheel is clearly outside the edge of the chassis. So what we're going to have to do is bring this motor in. So let's open you up again, our chassis base. Also navigate to it using this bottom bar. And let's just edit this sketch in here. Let's look, the sketch is over here. So let's just rotate our camera to go over here and bring it in a little bit. I don't know, something like that. Maybe you can even go a bit more. Who knows? Probably get away with like that. That's probably fine. Save it, and then over here. Now the way to update this is you hit this little lightning button, and it'll update, all the parts. And so now here, now that we've done that, we can see that, the wheel's completely inside with a little bit of space to go. This is perfect, really, because you don't want this like a millimeter away, just in case like something bends. Because the one thing CAD doesn't really simulate is bending, because these are all like solid, perfectly rigid parts in a CAD file, right? You can simulate bending, but that's a lot of effort, time, and kind of out of scope for this video, so I won't show that. So now here we'll just now put in this motor in, put in this wheel, and see how that looks. I already see a potential problem that we might run into, but we'll save that for when it happens. Let's just put these, line this up, hole to hole, right, hole to hole. Yeah, as you can see now, issue is that these two are clipping into each other, right? So what we'll have to do is just make this whole thing a bit wider because I can't push this out because this is here and, I can't really, do anything else, right, in order to separate these two. So what we're going to do is go here and make our whole chassis just a little bit wider to, accommodate that, right? So this is 192. We'll make it like 204. Give it a little bit of space. Now, generally, if you're like working professionally as a CADer, something you might know is this is very guess and check design. So it's not exactly the best of practice, but for something simple like this, where the specific locations of stuff aren't the biggest deal ever, it's kind of okay. It's not that important. Anyways, so I made that wider. Now let's push this out a little bit. Right here. I think I probably need a bit more space. Maybe make it like 42. Save that. See how this looks. Yeah. Now, actually, I did kind of leave some space here. What I could have done is literally measured out the exact distances that they were hitting, and I could have pushed it out by that much, but again, this is very simplistic design, so it's not that deep at the end of the day. I'm not gonna sweat over it. It's kind of faster to just quickly see it and make some adjustments. And, again, depending on the precision of your, design level, of what you're making, you can add more or less details. So in this instance, in order for this to point towards the center, right, this one's pointing inwards. This one, if I put this here, right, it'll never point inwards, it'll always point like this. So what we'll need is a left slanting wheel so that it, points in. Oh, left slant right here. And we'll just assemble that wheel on the same way we did the first one. So that interface to this face, and then we'll just take any, axis feature that's like, centered, and same with the shaft right there. Perfect. So now something to note here is that this thing is clipping into the wall, as you can see, this little plastic cover on the motor. So we just need to give some space for that so that it can breathe, and also the wires that they come off of these little, like, copper, bits over here. That's where the wires for the motors come out. So what we'll do is we'll open this and just sort of create a little cutout in there just so that there's space for that. So I'm gonna go in here and I'm just gonna make a little rectangle in here, something like that. Give it some quick dimensions. And something we can do actually is measure how tall this is. This would be the tallest point on there. So that's 12 millimeters. And again, better to just give some extra room than less room. So make it 24 or like 20. Not that important. And then just set it in by, I don't know, a few millimeters. It's not too important. You can even cut it all the way through if you want, but I'll keep it enclosed because, I guess it protects the motors a bit more if there's no like access from the outside to the motors, right? It's a little bit safer. So I'll just cut it in by 6 millimeters, right? That should be fine. I did it on the other side, didn't I? Yeah, okay. Anyways, we do need it on both sides. The one thing I will do is I will round these corners with the fillet tool, keyboard shortcut F. And this is more of just an aesthetics thing, to be honest. Makes it look nicer. I try to avoid having sharp corners on my designs too much, you know, especially with working with metal. There's a lot of reasons why you don't want to have sharp corners, both on a safety perspective and also a manufacturing perspective. It's hard to make sharp corners, but for 3D printing, it doesn't matter. It just, looks a lot nicer. Do that, Okay, now what I'm going to do is I'm going to mirror it to the other side. So this is where that whole like little spiel I had about like having your plane centered actually matters. So I'm going to hit the mirror tool, and now if I just click the origin plane of this origin plane, it'll just mirror all the way over like that. Shoot, I failed. Okay, probably just hit something wrong. Anyways, let me just mirror, right? And I'll click on the plane, right? This one right here, perfect. And for some reason, now let me try it with the fillet. I did it without the fillet. Now let me try this with the fillet. Sometimes mirrors are a bit finicky when you have, special features like the fillet included. Right, now let's try mirroring over here as one whole unit. Okay, it works. I probably just clicked something weird the first time because I was talking. But yeah, anyways, so now that's mirrored over. Right. So we don't have to, redesign it on the other side. It just kind of is there. Save that quickly. Look over here. And as you can see, there's a cutout for that. Let's see if it's long enough. No, it's not. You know what? Let's just quickly hide this and let's measure how long that is. The keyboard shortcut to hide a part in assembly is Alt-V, right? Or if you right-click, you see visibility right there, hides it. Yeah. Oh, I mean, you're probably wondering what that pop-up was right here. This essentially means that because this is an assembly right here, if I hide something inside the motor assembly of here, right, it won't update if I hit OK, is essentially what it's saying. Which I don't really care about for the motor, but I'll say no for now. I don't need to hide it. Anyways, let's measure this out real quick. This face to this face is 28. Actually, no. Actually, what we want to really measure is this face to this face all the way over here, right? And that is 56.9. Brilliant. Okay, now let's Control Z to unhide it, or what we could do is find it on the menu and hit Alt V again to visualize it. And let's go back here to the chassis base, edit this, and so 56.9. We'll make it a bit bigger than that, 64. Give it some space, some breathing room. Save that. But it is getting a hair close to this hole. So let's just quickly edit that a little bit, make it like 62. A little bit of breathing room is nice. Because again, that whole melting thing I mentioned, just, be on the safe side of things. Anyways, chassis assembly. Let us update that even though there's nothing really to move. And you can see that has, full clearance there and there's nothing, hitting. Right, perfect. And also with that extra vertical clearance that we put in, right, because remember that this thing is 12 millimeters tall, right? But we made 24, and that makes so that there's extra space for the wires to go through comfortably, essentially. In fact, we could even make it a bit taller, but it's I don't know. Yeah, we'll make it a little bit taller. Give the wires a bit of extra room. Perfect. Yep, and now we'll bring these over to the other side, these motors. So constrain this flat face, bring you right over here, right? Well, when I move that there, it kind of blocked those holes. I'll just constrain these first. This one right here, here to here, like that, and then just copy paste you again. Actually, you can like paste multiple times. I didn't need to recopy it, but I don't know. Yeah. Right here to here, right there. Move you out. Constrain you to there. And I can't see it, but I can just kind of move this until I can see it. And then do that to that. And we're back, and I'm a clown. I put this the other way around. Let's just do that again. Constrain you to here, right over here. Move you out of the way and bring you here. Yeah, that's just sort of a thing that happens in your CADing. It's very spatial. So, you just have to be aware of how you're, lining up those holes. Anyways, let's put in the wheels. So looking like this wheel, well, this will get flipped when I, because the yellow bit's on here, and this bit's what interfaces with the motor shaft. So realistically, this would go here because it'll point this way when I like mirror it over when I rotate it the other way. Let me just go back here. And again, like we did earlier, the inside of that bit all the way into here, right, and this to here. Yeah, I was right? No, I lied to you guys. I'm stupid. Yeah, no, that did not get mirrored. I'm a clown, a buffoon. Yeah, these are kind of like I don't know, bro. It's just geometry. My visualization skills were lacking. Anyways, this goes here, right? Because that clearly was not pointing towards the center earlier. Anyways, let's move that over. This is a lesson. Anyone makes mistakes, even someone as skilled and excellent at CADing as me. Anyways, there we go. That is right. There we go. Pointing in towards the middle. Perfect. And now let's get you right here. Let's see if we can see the inside of there again. Again, make another constraint. Hidden C. That constraints keyboard shortcut. And then, doing this. Oh, not that. Again, the axis, because again, it's just sort of a convenience thing. Also, because if I hit this and I have to find this, I have to find the exact, center. Or I guess I could do that, but, it's a cleanliness thing. It's a habit thing. Do what you like, I guess, in your own CAD models. But anyways, yeah. So now our wheels are in place, and this will work relatively well. But something to note about designing Mecanum wheels is that it is a good idea to have them as in much of a square of an orientation as possible, right? So that like they work evenly. As you might notice, it's kind of like a rectangle right now because we just kind of made up the dimensions, right? So what we can do actually is we can open this first of all, and we can essentially measure what we can do is we measure the center distance. And what we need to do that is find the center, make a plane in the center of this and use it to measure. Now for these wheels, I don't think I kept the center plane in the center when designing it because they were like really weird to design. So we'll just make our own plane. There's a bunch of plane making features here. We can make a mid-plane between two planes, like such, and we get a center plane. So there's that. this file, the assembly. And so from here, we can measure the distance between these two planes. We can even do now, of course, this is a different file because it's a different slant of wheel, so that didn't update on here, but yeah, that's 104.08 millimeters. That is this distance. Because, these planes are, infinitely long planes technically. This just gives a visual. So that's why you can measure this distance even though this plane's over here. So 104.8, and let's compare that to the center distance between, two wheels. Right here to here, that is 113.2. Now, to be honest, that's not that bad of a difference. Like, that's kind of the same thing, not gonna lie. Like, it's not gonna make a difference in your performance, but if we want, we can, line that up perfectly. This gap is looking pretty small, so what I'll do is I'll actually shrink it in a little bit to, line that up perfectly. So 104.08, and I need this to become 113.2. Okay, so we can pull out a calculator real quick, do some basic geometry. Calculator. So 113.2 minus, well, what was the number? I have like the memory of a goldfish right now. Give me a second. Okay, 104.08. Right. So that's so we need to increase this length by that much, and then we'll get that extra I hit. Oh my god. Okay, 9.12. Okay, that's how much we need to, increase this distance by, I believe, to get it there. So let's just edit this. Remember how I made these? Wait a second. We want to make this one longer. Okay, so first let's get into here like this, and then now let's edit the sketch. I want this to be longer, but note that I actually did make this equal to this because I thought I wanted a square. And I mean, it does work, but whatever. I'll just make that to there. Sometimes we change our minds. It is what it is. So 9.12. So what we can do is we can actually write equations in here and it'll like do the math for you. If you don't put units in, it'll just assume the default units of your settings, which for me is millimeters. So I'll add that. I'll make it like that. It'll adjust itself. Save it. Go back to assembly. Like that. So now we can measure. 113.2, and then over here 113.2. Perfect. They're perfectly centered. This is great. It's a square. Okay. Yeah. Anyways, I'm gonna go back in here and just hide this plane. Not gonna lie, I might actually just make this plane for you guys if you guys in the actual file I'm gonna distribute. I might or I might not. Who knows if I forget. But anyways, yeah. Save that. Brilliant. So yeah, that's the wheels. The next thing we'll do is create that bottom section for our electronics to sit in, right? So we'll just kind of edit this again, and here. So let's just open this up and let's just see where the wheels are located. So we make cutouts for those two while we're here. So let's just measure this here to this at wall is 25.2. So we'll, okay, 25.2. And then this wheel is 29.5 millimeters wide. So what we'll do, go back to here, make a 29.5 millimeter wide I forgot how long, what the diameter of the wheel is. I did not measure that. But anyways, the cutout for the wheel, so the wheel is 29.5 millimeters. We'll make it a bit bigger for security, though. To be fair, the wheel, when it hits the bottom of the chassis, won't be the full diameter, but like whatever, it's fine. And then let's measure this diameter. Now the diameter of a Mecanum wheel is kind of awkward to measure because, well, there are like 50 million rollers. So what I'm gonna do is just kind of make a sketch and get like an approximate answer. I mean, I could project this geometry here and this geometry here and like get an exact answer, but like whatever. It looks to be 64 millimeters, and since I CAD'd it, I know that it's probably 64 on the dot in the model. Note that this model I made by purely measuring the wheels we bought off of Amazon, so this model might not be like millimeter correct. And in fact, the actual shape of these the outside of these wheels here is not exactly the same as on the wheels, because those were really annoying to design. But this gets you the general idea, of all the important dimensions. So anyways, yeah, 64. Bro, my goldfish memory. I almost forgot that number like the instant I told you guys. Anyways, 64 right there. Okay. So I know that's 25. I forgot. I need to like have like a notepad open for this. I forgot what I measured. Okay, let's go back here. Over here and over here and 25.2. Okay. Back to here. We'll make it 25 to give it some space. 25. Okay. Yeah, we gave it some extra space there, so we're chilling. I remember I mentioned that we could have made this exactly to size because of like the wheel diameter, but I realized that the diameter is on this side, so it actually like needs to be long. It can be 64 on the. It can be right on the diameter on this side, but the width is not changing, no matter how the wherever it is. So this one actually does need to be longer. I'm just a clown. Anyways though, I don't know. 36. Give it lots of space. Give it lots of space. We're not stingy at all. There we go. I don't know why I finished the sketch. We're still working. Anyways, as for the this way, I forgot because I'm a clown. I did not measure that. Let us measure that. Let us first make this plane visible, and then use our measure tool here to the center of this circle. Is 56.6 millimeters. Great. I actually probably could have measured that in the file I was in, thinking about it. But anyways, whatever. 56.6. I can't write, type, whatever. Okay, there's that. And now, I'm gonna mirror this across. Yes. That will be the best way to do this in this instance. So I'll mirror this across and then over. Now I'll actually do a different feature just to show you something new. Mirror. This is a mirror line. Apply that. I'll actually make this construction. You can also mirror over a construction. I could have made a construction before, but I just kind of forgot. Anyways, yeah, so mirror that, and then something we can do is, okay, so we're gonna select these four right here. And select U4. I could drag select over everything, but I don't feel like carrying the X's over. Anyways, what we can do is a circular pattern, where essentially, what this does is, it kind of, actually, I feel like a easier way to show what this does is, it makes a patterns in a circle. So you click on a point as like the center, and then it kind of just like brings it in a circle, essentially. So we can do that and then include these guys. And if we do a circle with, let's click on the middle, with 2 elements, it'll get mirrored across. Well, not mirrored, but since this is symmetrical, it gets mirrored. So it's fine. And I just kind of wanted to show you that circular tool. And it does prevent us from having to make another, construction line here, and it keeps it kind of clean. Yeah, anyways. Now let's project these 4. This one's already done, and I'll just make this on construction. So, what this means is that we can finish. I'm thinking about it. Actually, I don't want to do those 4. Actually, I'll do the outer 4. I'll make it cut down I'll make it go down a bit instead of go up a little bit. So I'll do this instead, and I'll make it go down by, that 6 millimeters does look fine to me. This isn't too specific, really. Yeah. Save that real quick. Come back here. Let's close out of these. I don't want to save anything. Yeah. Note that because we kind of guessed these dimensions, it's a bit off center. That kind of annoys me. I'll kind of fix that. I think I need to bring this in by like 1 millimeter or so. I think. Yeah, that's roughly centered. Perfect. Yay. And we have a bit of ground clearance here so we can drive. We're not climbing over any terrain, so we don't need these wheels to be exposed at all. And actually, that's why I designed them for you guys to have them inside your chassis so that, this doesn't, get hit by other robots and it gets damaged or anything. So it's a good idea to have your wheels not exposed. Yeah. Anyways, I'm going to hide this real quick. Save view. Okay, so the next thing we can go for is sort of designing the space for your PCB to be located just in there. Because, yeah, we added this little section here just for a housing for your electrical stuff. Right, so import electronics. Okay, PCB. Okay. Give it a minute. It's kind of a big file, actually, I'm pretty sure. Because it has, like, all of the electrical components on it. It takes a minute, You can, I don't know, take a break for, like, a good, 2 or 3 minutes. I don't know, scroll TikToks or something. I don't know. Yeah, just have fun. I also do actually wait. No, it's fine. I thought there was a mistake there that I made. No, there's nothing. I don't make mistakes. I'm perfect. Anyways, this is getting kind of awkward. I mean, I'm just kind of. This really is not loading in yet. Hello, please. Yeah, this is taking a minute. It is a big file. Yeah. Yeah, I don't really know. We are literally just waiting. Okay, here we go. I thought, here we go. Okay, there it is. Okay, perfect. Brilliant work. Anyways, yeah, this is our PCB. Yeah, so what we'll do is, now it actually has mounting points on here. These 4. So what we can do is measure out where they are, but I'm not going to do that yet because I know I will forget that number instantaneously. So what we'll do is we'll actually place this on the bottom. Note we'll put the, not this face, but rather this face, because on the pins, because it'll be sitting on those pins. So right there. Note it'll actually like not be sitting perfectly flat, because well, that's not a flat surface, but like it's not that deep. It's okay. We'll kind of rotate this over, and not as like a constraint, but just kind of more of like a visual thing, so we can kind of see it. 90 degrees. Okay, so is there enough space? There is enough space. That is good news. Okay. Motor ports here and here. Yeah. Okay. Perfect. Yeah. So now what we can do is we can make holes for this. 50.165. That's oddly specific. Okay. So 50.165 by 92.329. Ain't no way in hell I'm memorizing that, but okay, let's just go one number at a time. 92.329. I think that's the number. I could be mistaken though. Let's just make a sketch here. And we'll make, I exited out on accident. Anyways, yeah. 92.329. And then let's measure the other one again. Right here to right here. 50.165, and let's just make sure I measure the other one right. And by that I mean I remember the number right, because we all know how bad of a memory I have. 92.329, I think I put that down. And this one's 50.165, right? 50.165, brilliant. Okay, let's do that. 50.165. I think that's the right number. Well, to be fair, it's not like anyone's really making this chassis, so you know what? It don't even matter. Like real talk. If it's off, it's off. Like no one's gonna care if something's wrong on this one. Anyways, we'll put some heat set inserts in. Those were also 3mm holes, if I remember correctly, so use that same dimension of 4.5 to, put the inserts in, did the space for them. And so what I did here is I just made a rectangle and put the holes in the corners, and that's just a really easy way to, dimension all that really conveniently. So yeah, anyways, I'm gonna extrude that out downwards, through everything, through all extrusion right there. Brilliant. Okay, I will save that, and over here. Now something to note is, given how oddly specific that measurement is, and there might be more decimal places to this measurement here than actually shown here. So this might not exactly be 50.165 millimeters. This might be like 50.1623987, millimeters, right? And it just doesn't show that many decimal places, which means it might not work with the constraints because the constraints are very exact. God, I'm dying. Okay, anyways. Oh my god, I need water. Anyways. God. So I can put this here, right? And it'll line up to that hole fine because that's an axis to an axis. But the thing is, right, that means, okay, it's limited to this, like, circle. Right, so now when I put in, you right here, right, it might not exactly, oh, it does. I don't know, I guess it does. It is really that specific. I guess Logan really made these holes. Let me measure that again. He made these holes 50.165 millimeters apart for some goddamn reason. Like, this is an exact number. That is the real exact dimension. Anyways, I guess it works. I'm a clown. Anyways, yeah, that fits in perfect. Um, yeah. But just as a general note, when you're CADing stuff, and and you use an imported part, an imported CAD file, and they have like a really specific dimension on there, it might be made in like a different unit or something. And like if you make measurements and design a thing, it might not line up properly, right? Is what I was trying to teach y'all, and then my whole lesson got ruined. Anyways. Now that the PCB is on there, let us quickly save. And I'm actually going to do something real quick to this. It's not really a functional requirement, but it's something from designing my demo bot that y'all saw at the Mech Workshop that I noticed was a bit of an issue. It's wire management, actually. So what I'm going to do is I'm going to make little towers on here to guide the wire so that they don't hit the wheels. So they're safe. So I'm just gonna make a little this guy right here. It doesn't gotta be anything crazy. 32, but I forgot to hit tab to hit the other one by like who knows? I can make it like whatever, and I'm just gonna line it up to you for no good reason, but because I feel like it. And then line it up to you just to make it look nice. And then I'll have you, and then actually I'll extrude this out, make it like 24, sure. And then I'm gonna cut a little hole in there, right? I'm gonna project this stuff, and I'm gonna find the center of that using this, just making some reference geometries. I'm making it, something like that. Interesting. And then I'll use the to face feature, so it'll cut only to this face, right? And something about these, these lone struts here is if you add a bit of a fillet, it increases the strength because that's more surface area that it's, contacting on the bottom. So yeah, that's a nice little design feature you can use when you're modeling. Let's just quickly check that that's not hitting anything. Technically, no. Once again, I will say, maybe if you're really designing this, you move it back a bit just to be safe. You're not building this chassis. It's fine. Or maybe you are. Who knows? Anyways, I don't really care. I'll kind of just leave it there. Not going to lie. It's not that deep. So yeah, I'll just mirror this over. You know what? I am going to move it back. Just in case. I'm just because I can. Well, not really, but let's just move that back. I'm going to delete that vertical constraint and just push it back just a little bit. make that a dimension right there, and save that. Give it a little extra space. Yay. Okay. And then maybe I can make that look a bit nicer. You know, fill at the top or something. Give it some like a little like rounded corners up there. Yay. Yeah, that's neat. Uh-huh. I'm just literally investing in like making this look pretty for some reason. I don't know, maybe like the chamfers look nicer. This video is like probably gonna be an hour long. I don't know why I'm like nitpicking over how it looks. Anyways. Yeah, let's mirror this guy over. Uh-huh, right here. I think I also need that, yeah. Oh my god. Select all of you. Mirror. Oh, is this the one? No, this is the one. Brilliant. Okay, and something we can also do is chamfer the inside of these so it's like safer for the wires. That is something we can do. It's maybe not that deep because it's plastic, so it doesn't really matter as much, but if you have like wire holes, you should probably like chamfer or fillet them down so they're a bit smoother, right? Yep. And so that's that. We're almost done with the chassis actually. There's like one other thing that we need to do on here before we're done with the chassis, which is adding our IR sensors, which are, you know, a rules thing. You have to have them on or else your robot is illegal. um, Let me actually quickly look up the exact rules on where you need to place them. Let me just pull this up on my phone, like real quick. I gotta find the rule book. I'm pretty sure it's supposed to be placed around 3 to 4 centimeters up from the ground, off the top of my head. The rulebook PDF. It's on the Internal Comp Discord server, and let's see. And you should be able to find the rules for, you know, the actual specifications of the robot in, you know, Section 5 Starship specifications, right? So in there it says 4 to 6 centimeters off the ground. Okay, that's the ruling, right over there. Okay. So let's open you up. And actually, let's open up the model I made for the transmitter and receiver, which is actually the same exact model because they are the same exact size. It's just that they look slightly different. Yeah, whatever. And yeah, I didn't include like the little sensor bit in there because like I'm lazy and I don't think it's that deep. You don't need the little like light bulb on there. Just put some extra space clearance on. You'll be fine. It's also on the outside of your robot. It's not going to interfere with anything. My bad, y'all. I did not feel like having the little like light and like electronic bit coming out the end. Okay. Anyways, so let's just measure this real quick. 15 millimeters is the separation, and I believe there are 3 millimeter holes. Yup. So let's so what they have to be is they have to be first of all centered on each side of your chassis. So we'll start with the transmitter. So the transmitter goes in the front. I realize that this is the back face. It's not really that deep. I mean, as long as we designed the front to be the front, it doesn't matter. But I'll follow the convention shown. And now let us, you know, do this. What is it? 15 millimeter separation, and then we'll use heat set inserts right here, right right, line that up in the middle, and then so something to note actually is that the distance from the ground is based on the wheels. So the wheels are 64 millimeters, right? And so let's actually project where the center of the wheels would be, which is here. So this, right? And then make a line that's 64 millimeters long. So this is where the, no, 64 for the radius. Okay, this is the ground, right? So what we gotta do is first make these construction, because we have best practices around here. We use good practice. And then after this, we're gonna do, I don't know, 4 centimeters. That's fine. And note that if you look at this model, these are kind of on the bottom. So, I mean, and we can measure how tall this is. This is about 2 centimeters. So the sensor will be in roughly this location, which is smack in the middle of 4 to 6 centimeters. Right, so we'll put this in here. Right, and note if you do not put your sensor in a legal location, then we'll find out at the inspection table. So I'll make sure you're doing that. So yeah, we'll bring this across because symmetry, yay. And we'll kind of actually we can do this like a pattern, right? So we can actually do this to this face back here, right? Well, it goes there. And then we can circular pattern U, right? Select this feature, and then we make this 4 units like that. That did not work the way I intended it to work. Hello. That is strange. Well, I guess that was a failure of an attempt. It did not make the cutouts. That's the issue with patterns, is because it's kind of assuming the same geometries on each side, but this is like wider than this, so it didn't really work out. It kind of needs the exact same thing, especially with these 3D patterns, right? It's not gonna. You need things to be lined up perfectly for it to kind of work. And as I kind of already mentioned, right, we made this longer than this to make the wheels line up, centered with each other in a square. So yeah, we'll just have to do it, manually, which is, it's fine. Let's do this here. This is 15. Line this up like such. Make you a construction line. And then I have to make this whole like 32, which is half of 64. So now let's make you guys construction. Dimension U off of the bottom of this right here. And what did I say? 4 centimeters, just 40 millimeters. Right there, drawing our little circles. It should be 4.5 for those heat set inserts. Right over there. Perfect. And something to note is I don't think I can just extrude all the way through because it'll, eat straight through that. So we'll just have to go to this face right here. And then what we'll do is we'll actually just mirror this across. I keep on taking the wrong planes. Okay, right there. Perfect. Perfect. And it's fine that it's over here. And we gave a lot of clearance. As long as the screws don't go past, we're all good. Yeah. So anyways, yeah, let's save this. And we'll go over here. update that, whatever, save it, and we'll import our transmitter, which is the same as our receiver. So I'm not gonna lie, I probably might not even bother importing the receiver because it looks the same as the transmitter CAD. Anyways, let's just put you here, and then you here, right? You know, I'll do it just for the sake of OCD, you know. I mean, there is physically zero difference between the two, but just for the sake of our inner desires, we'll do it. Anyways, here we go. Here we go. Okay, actually, you know what? Forget that. I'll show you something cool. Yeah, check this out. Remember that circular pattern thing? We'll do that here too. Yeah, let's find it. Let's find an axis though. Yeah. Yeah, oh. Yeah, again, we're noticing the fact that this is not perfectly square-like because, you know, we made this side longer than this side, so it does not work. How do I keep goldfish memory? That's what I tell you. Anyways, let's give up on that, like the failure that I am, and let's just redo that, and let's just go back to doing this. Now, I just wanted to show you my cool circular pattern feature. And every time it just fails. You know, it's just like that sometimes. Anyways, let's just put you to you. And then put you to you, like so. And then let's paste you, like such. And put you to you. And you to you. And yay, we've made a chassis. It should work probably. I mean, it would work, definitely. Trust me. I mean, I haven't built it or anything, but like, theoretically, it is a working chassis that you guys could now make and use for your internal comp, and this is a perfectly legal internal comp robot. Would it win? No, but it is a legal internal comp robot that would perform. Well, you also need a battery, actually. You would go on top of your chassis, but we'll kind of design that stuff in the next video because that's sort of like where your arm goes. But yeah, your battery would probably go on top, or like maybe if you can maybe fit it in here, but this is kind of a small space, which is why you probably aren't going to put your battery in here. And also because of just like accessing your battery, you do that more often than you access your PCB sometimes. So yeah, but anyways, yeah, that's it for this video. You know, we can maybe make this look a little nicer. Add some chamfers to the corner, you know, make your robots look nice, you know. That's the fun part after all of this. You know, make them look cool, you know, add some chamfered corners and everything. Yeah, look at that. He's looking clean. Okay, yeah, I'll save this and yep, that's perfect. All right. I hope you guys learned something about how to design your chassis, and in the next video we'll be designing an arm mechanism.